Welcome to another video. I'm just getting up to speed with this device, this Samsung device. What we're gonna do right now is do a little electricity video. I'll try and be brief. Let's begin with a simple Ohm's law video. Let's create a really simple circuit. This here is a battery, and this here is a resistor, and we'll put another resistor, and you always have to put your ground. These are the symbols. Let's make this a 9-volt battery. And you always have to have your polarity. And the negative is always on the short terminal and the positive is always on the larger terminal. So Ohm's law is V equals I times R, where V is the voltage, I is the current, and R is the resistance. Let's give these resistors some value so we can compute the current and the voltage across each resistor. So we'll give this resistor something like 5 ohms. Ohms is the unit for the resistor. And this other resistor will give it something like 4 ohms. So one important thing when working with a circuit is to ensure that you assign the the polarities that are gonna that you assign the polarities on the resistor. It doesn't matter how you assign them. What does matter is that you assign them and that you remain consistent. So let's put a positive right here and the negative here, and a positive here and the negative here. And and there are two laws for computing the voltage and the current. One is called Kirchhoff's current law, and the other one is called Kirchhoff's voltage law. We're gonna begin with Kirchhoff's voltage law. Basically, what it says is that the sum of the voltages in a closed loop is equal to 0. So let's draw a loop here, and now you sum your voltages. So as we go through the loop, we see that if we start from the ground going up, the 9 volts is a rise because you go from negative to positive. And then when you go to the 5 ohm resistor, continuing where you were, you see that that is a drop because you go from a positive to a negative. And the same is true for the 4 volts. So the way that I do this equation is you put the sum of the voltage rises is equal to the sum of the voltage drops. And there's only one rise, and that is the 9 volts. And that is equal to, well, I forgot to assign the current. Since there is only one loop, the current is the same through all of them. So let's give it a little arrow and we'll call it capital I. And using Ohm's law, the voltage is equal to the current times the resistance. So if we multiply this by the current, we get V1, the voltage across this resistor. And if we multiply this by that current that's going through it, we get V2. So I'm gonna drop the ohms right here, and this is equal to just 5i, and this is equal to just 4i. And I'm gonna drop the volts here also, and so I say 9 volts equals to 5i plus 4i. And the only unknown is a current, but we can solve this because we have one equation and one unknown. So you get 9 equals to 5i plus 4i, which is 9i. Divide both sides by 9. And what do you get? the current is equal to 1. And when you have a volt divided by an ohm, that is equal to an amp. So the current is 1 amp. And from there we just found out that the current is equal to 1 amp, and your V1 is equal to 5 times 1, which is equal to 5 volts, and and your your V2, it's 4 times I, which is equal to 4 volts. So as you can see, these 9 volts gets divided among these two resistors.